Hello, everyone. Thank you all for being here. Today, Chinmay and myself, Soumya, are going to talk about a very exciting topic that in the context of zOS mainframes on how to build and deploy agents for zOS in just minutes using Assistant for Z, watsonx Assistant for Z. What I'm going to do is start out talking about some aspects of the technical evolution on how where we started with models, machine learning, and where we are today with agentic AI. As I understand, all of you guys who are listening in are developers and I don't know how many of you are aware of the mainframe ecosystem. So, for those of you who are aware, that's awesome. For those of you who are not, mainframes are IBM's flagship operating system running on zOS is IBM's flagship operating system running on IBM mainframes, and they've been around for over 60 years, and they are core to the way many enterprises, especially financial organizations, insurance, and banks, certain many governmental agencies operate. So the easiest way to relate to mainframes is, when you're using an ATM, when you're accessing your bank account, there's always a mainframe that's running behind the scenes to give you what you need. So that's just about the mainframe. So now coming into, how um, the ecosystem is evolving or the user experience is being transformed, but with the power of generative AI. I'm going to start out, as I mentioned, starting with an evolution on how we landed, where we are with agentic AI, and help relate to agents in a way that is going to flow into what Chinmay is going to talk about right after me. So, the models that we use today have evolved from where we started out with machine learning, smaller models that were tuned and trained to be really good at problem solving, matching patterns and logical thinking. And I think the easiest way, again, to relate to this is where you have fraud detection use cases that are powered by um, models, these models. And from that time, we moved on to the building and usage of assistants, which were really good at having enabling an interactive mode of operation with any system, and where you could ask a question and return a response, receive a response in return. And the one additional thing that assistants were also really good at is performing prescriptive tasks, which is, there is a point automation that's running, where based on the user's question, the assistant is able to map to the right automation that might be related, and is able to trigger that automation with input from the user, or come back to the user after the execution of that action is complete to display the output. So it was more of a single step process along the way. And from there, we very quickly moved into this agentic mode of operation. And I'm sure most of you here that are listening in have, agent has been a buzzword since since probably fourth quarter of last year, and it's evolving very quickly. And also the large language models that are backing or powering this agentic AI are also evolving really quickly at an unprecedented pace. And what are agents good at? Agents by themselves, the terminology in technology is not new. Agents, they're autonomous programs that are capable of running based on certain triggers, automatically or autonomously. And the with the agents, and combining the power of the agents and the generative AI or large language models, the agents are capable of performing many step actions or automation that are multi-step, and are also able to plan and reason and course correct along the way to if it is able to plan a certain path depending on what the user is asking. And along the path, if it fails or if it detects that a condition is not met, then it is able to understand that and course correct to the next best action. And that is where we are headed, and the entire industry is head on trying to figure out what are the best use cases for these agents, and how to put these agents to use for the benefit of the enterprise. And the easiest example to relate to agents is, we've all interacted with travel agents, sometime, one time or the other. And when you go to a travel agent, who is your front face, and you give them a set of requirements on what kind of where you want to go, or what are the kind of places that you want to go to, what are the type of things you'd like to do, and how many people, and modes of transportation of preference. All these details you share with that person, and now once all your requirements are collected, your travel agent goes off and starts planning your trip, where they are able to do certain things by themselves, maybe flight bookings or um, rail bookings. They're able to do it for you. But the when it comes to the next phase, say you're going to another city, where you've got to plan certain local activities as part of planning that trip, then they reach out to other agents or their friends in those places to get the information or to take their help to make certain reservations at restaurants or cruise lines or whatever it is that was part of your requirement. And then ultimately, after all this is done, they gather all that information and present it back to you, either in terms of options. Hey, here are a couple of places that you could go to, and these are things that you can do. Or if you had given them a really deterministic, okay, this is exactly the place I want to go to, then they are able to actually present back that playback that itinerary that they have booked to you. So that is how the agents are, agents in the whole agentic AI vision are also expected to work, where the answer to a certain question may not lie within everything may not lie within a certain agent's awareness, but the agent is able to tap into other agents or tools in order to for it to get the responses, and then compile them, analyze them, put together the recommendations, and share it back to the user. So the now coming relating all this back to watsonx Assistant for Z. So watsonx Assistant for Z is a product that is focused in the Z domain. And the Z domain is not a single product, and that's why it's called a domain or an ecosystem. It is about 200 plus products that are in Z infrastructure, hardware, and software that work together to actually build this ecosystem. And with Assistant for Z, there are two key aspects or areas of focus. The first is to be a general purpose assistant for and provide responses to users' questions that are all grounded in Z and Z domain knowledge, and the users, your own enterprise's domain knowledge. And the second aspect is the automation integration. So earlier, when I started, I talked about assistants and how assistants are capable of performing single step actions and also be able to respond to users' questions. And the integrated automation aspect of it, where when the user asks a question, it could be anything. They are in the process of learning about a concept, or a terminology, or about how to handle errors, whatever it is, from on in their mainframe environment. Then, and if there is an automation that is in the awareness or catalog of Assistant for Z that is actually capable of handling or taking that action, then the assistant is able to automatically map the user's intent to the description of the automation that's in its awareness, and recommend it to the user. And that is what is evolving into this agentic AI, where the agents can capture the user's intent, gather the necessary context, and can go off by themselves, trying to figure out what is the best path, or what kind of information is it able to provide back to the user. It could be tapping into knowledge base, as the RAG that is part of the Assistant for Z, which is grounding all of the questions or Q&A in Z domain. Or it could be actions that are published by the multitude of agents that are going to be um, surfacing through Assistant for Z. And to further give a little bit more detail here, and again, I am fully aware that some of you who are listening in may not be very deep into the mainframe ecosystem, and that's why Chinmay is going to talk a lot more about the development aspects of these agents after me. But to kind of level set what Watson Assistant for Z is doing, is I mentioned that it's going to be the platform on which the agents on Z come together. So if you think of your mainframe as the place where all of your software, your tools, your applications are all running, and Assistant for Z is the agentic runtime. The way they all the agents or the teams, the core software and the middleware teams, like the DB24 zOS, CICS, IMS, and a lot of our performance and operations tooling, specialized tooling in that space, are all building their agents with a set of tools which are going to be surfaced as MCP servers. And the tools from these MCP servers are going to be tapped into by domain agents, or agents that are focused in a certain domain space, like application development or operations or capacity planning, or just system configuration. And it is going to as the tools are getting used by these domain agents, then and the user poses a question to the Assistant for Z, then these agents are able to figure out the orchestrator is able to figure out which is the right domain agent to go into action to respond to the user's query. And then as the agent goes into action, it'll tap into these tools from these various MCP servers to figure out what needs to be to plan and execute the respective tools to gather the responses from the live mainframe system, and bring them together and provide back the user with an analysis or recommendation, whichever is the appropriate response, um, to close that interaction. And all along the way, there's going to be three aspects or three components that are going to be central in this entire story, which Assistant for Z as a platform will provide, which is going to be the RAG, retriever augmented generation, which is used for all of the content grounding in Z domain. And that is built centrally, where all of these agents or users in general can also bring their documents, in addition to all the Z focused documents that are already in the RAG. And that way, it is not just grounded in Z, but it's also grounded in your content of preference, or need for the enterprise. The second component is the topology, where the topology server is going to have the awareness of the enterprise system, and that is going to be made available to all the agents centrally, to understand where a DB2 for zOS or a kick system is running, and which part of the enterprise or system or subsystem these are, and what are the runtime parameters. All of this is going to be discovered and maintained in the topology server. And the third being identity management. And for those of you, again, who are not very aware of the mainframe ecosystem, the the security, the authorization, authentication, um, details are maintained specific. Mainframe is another server, right? So all of this is handled, the user management is handled differently on the mainframe systems, and it is a highly secure environment, which is why it is one of the most preferred enterprise backend system. And because of the nature of all of these agents and Assistant for Z running on OpenShift and typically on distributed platforms, the need to map the user's distributed or login ID to the mainframe ID at the time of execution, so that every call to the mainframe is still auditable. The agents are running on behalf of the user, and all that is maintained. So those three services are going to be central service provided by Assistant for Z as the runtime platform, and is going to be available for to all agents to access it in a similar way. So I'm going to in a minute I'll be handing it off to Chinmay. So this is all of the vision and where we are headed with agentic AI, and mainframes have always been cool, and this is yet another place where mainframe is at the forefront of this generative AI and agentic AI technology usage. And what Chinmay is going to do now is going to take us through how to actually build an agent and deploy it on Assistant for Z and interact with it. So Chinmay, off to you.
Thank you, Soumya. Hi, everyone. Today we will be going to have a live walkthrough of how we can develop the agents using Agent Development Kit. watsonx Assistant for Z leverages watsonx orchestrate capabilities, which will bring in the Agent Development Kit. By using that, we can build the agents, build the tools, and manage it with very low-code approach. So I'll be sharing my screen and will be walking through how we can develop the agents. To start with, uh, I believe we all know at this point of in time what is an agent and what are all the building blocks of an agent. In short, tools and prompt serve as a foundation layer for an agent. Now, moving on to what is an ADK, Agent Development Kit helps us to develop the agents with a low-code approach. It helps us to build the tools, manage the tools, and if the tools are leveraging any external API calls, it will help us to manage the connections, and it will also help us to validate in our local laptops, and also it will help us to deploy it on our live environment. With that, I'll move on to how we can set up the agent development kit. First thing, we can talk about the prerequisites. As part of the prerequisite, first thing that we need to make sure is the laptop or the computer that we are using meets the suggested hardware requirements, and the agent development kit brings in few containers into our local development environment, and for the same reason we need a container runtime like Docker or Rancher desktop if we are using a Mac OS. So this document has steps to configure the ADK. By using that, I have configured the ADK in my laptop, and after that, I have configured this environment variables which are needed to deploy the agents into a live instance. Now, coming back to the capabilities of the agent as the agent development kit, as the agent development kit helps us to build the agent, we can develop the agents in two styles. One is a planner agent, which is basically acts as a supervisor agent, and another one is a collaborator agent. So we can have the collaborator agent working together and guided by a supervisor agent to complete a complex use case. And also coming to the tools, we can import the tools by having the set of tools defined in the Python files, or let's say there are some APIs and you want to leverage them as tools in your agent. We can directly import the open API specs for those REST endpoints through the ADK and use them in our agent definitions. With that, I'll move on how we can create the environment configuration for using the ADK. In ADK, it supports two kinds of environments. One is local environment and other one is the remote environment. The local environment is your development local laptop instance where you can develop the agent, you can start coding and validate it and test it. Let's say once everything is developed and tested and you want to deploy it on a live instance, and you can add an environment for that to move your draft developed agents into a live environment. So to do that, to use the local environment, we can issue this command env activate local, and then it will connect to our local instance and we can start building the agents. And if you want to add a new remote environment, then we can create a new environment by using the by using the env add command, we can use a remote connection to add into our environment instances, and then we can activate that remote environment and then move all the agents. And in a few minutes, we will be seeing all those things in a live. So to start off with, once we have all the prerequisite and the configuration setup is done, we can install the CLI for agent development kit by using the pip install command. So here the document has the guidelines how we can configure how we can install the package for the CLI and configure the complete ADK, which we have discussed now. And so by using this command, we can install the CLI. I already have the CLI installed in my local. So the next thing that we can do is we can start the orchestrate server. And while starting the server, we can pass the env configuration. So this env file will contain the contain these environment variables based on your entitlements, which are needed to pull some container images and which are needed to deploy your agents into a live environment. So with that, I'm issuing the command to start the orchestrate server. So it is logging into the Docker registry and it is pulling in some containers, and it has started the server successfully. Now with that, we can start creating the agents in our local environment. So for that, first I need to activate my local development instance. So this has successfully activated the local development instance. And now with that, we'll move to the development of the agent. So for today's walkthrough, we are developing three agents. One is a topology agent, which is basically interacting with, which has a tool to interact with a zOS endpoint and gives us the system topology details of a zOS system that we have configured with. And we have a ServiceNow agent, which basically interacts with the ServiceNow REST APIs to do a incident lookup or incident creation. And finally, we have a planner agent, which basically orchestrates or plans out the user query to distribute among the topology agent or the ServiceNow agent. So with that, I'll go through how we can create the tools. tools can be simple Python files. So if we have seen some examples in how we can create the tools by using LangGraph or LangChain, it is following the same fashion. So we need to have the Python functions defined, which is annotated by that the rate tool annotation. And we can have our function logic to do the specific task that is intended by the tool. And for this, here is my get system topology function, which is basically interacting with the REST API to get some system level information. And to interact with this REST API, I need to connect to that REST endpoint with an authentication. And to do that also, the ADK supports us by by helping us adding the connection. So here we have the sample command to add a connection. So if I have to connect to a REST endpoint, I can create a connection name, and then I can pass the connection URL, and I can and in the kind here here we are passing the credentials type. So if the REST endpoint supports basic authentication, we can pass in that, or if it supports a bearer token or an API key based mechanism, we can have it here. And with that, we'll be able to add the connection. And also one thing to notice here is we need to mention the environment type here. So either this can be a draft or live. So when we are working in a local instance, we can set it to draft. And once we want to deploy to a live instance, we can migrate the existing connection by changing the env type to a live in the CLI command. So as I said, here is the tool. And once we have the connection added, we can uh, map that connection to the tool by using the annotation. And with that, we are good to import this tool. And a tool can be imported by a simple command like orchestrate tool import, and then -k stand for the kind, and we can import the Python. If it is a Python file, we can specify the kind as Python and provide the file path for it. And in case of if the tools are in a OpenAPI spec kind, then we can change the kind to that and provide the file path over here. The next step is once we have these kind of tools, the next step is to create the agent. Before that, I'll just walk you through the tools that I have for the ServiceNow agent. So we have got a couple of tools that is for to interact with the ServiceNow APIs to create a ServiceNow instance or to get the details of a ServiceNow instance. Now, as these tools are ready, the next step is to create the agent. So creating an agent is as simple as creating a YAML file. So here it has a style, which can be a React and default. And in case of React, it comes up with a standard React-based prompting style where the agent works in a chain of thought action and completes the intended task. In case of default, it just follows the instructions that we have given to complete the task. And the next thing is the name. So this is the name that we want to have for the agent, and then the LLM. So this is the model that we are currently using. And then there is a description, which basically talks about what is this agent is all about, and then the instruction. So these set of instructions are basically for providing an instruction about how the agent should use the available tools, or if there is any specific requirement for formatting the answers. All those things can be provided as part of this instruction. So this is basically a place to add your prompts. And similarly, we have this topology agent. And now in the Z software agent, what we have done is we are just adding the ServiceNow agent and topology agent as collaborators, and we have given the description saying that the orchestrator agent can work with the topology info agent and the ServiceNow agent. Then we have some instruction to some ground level instruction for the planner agent. Now with that, once we have this, here I have a script which basically does the import part, and the agents also can be imported by the agent import command by specifying the file path. So with that, I will be executing this script to import all the agents and tools onto my local instance. So here we can see that it is logging that it is using the requirement file. And okay, I forgot to mention about the requirement file. So if the tool is using any specific requirements to add any dependencies, we can have the dependencies in the requirement .txt the same way how we add the requirements for other Python applications. So here we can see that it is importing all the tools. It is currently importing the ServiceNow related tools. And it has completed importing all the tools and the agent. And since I had already imported it once, it is currently trying to updating the existing tool. With that, we can just do a chat start. So this will open a local host 3000 instance where we can see the UI to chat with the agent. Now I can see, we can see here that we have our orchestrator agent, and here I can pass the query. So now the expectation is this query is to get the incident details from a ServiceNow agent, and the orchestrator agent basically comes up with a plan of action to use the ServiceNow agent and passes this incident ID as an argument to the respective tool. And once the tool execution is completed, it gives us the response, which is surfaced by the LLM. And this will complete one action of the agent. And here we can see that the agent has responded with the incident details, and it also shows the reasoning for it. Here first, as we are expected, the query has routed to the ServiceNow agent, and it has extracted the incident ID, and then it has selected the tool as well to get the incident details by number. And once it has fetched the incident details, now it is transferring back the flow to the supervisor, which is our Z agent orchestrator. And with that, now we have got the final response. So this is how the typical flow of an agent. And as you see, once we have the tools ready, it's almost about a minute to create our agents, and we can see that agent is up and running on my local instance. And similarly, I can ask the question to check whether the routing is working for the other agent that we have. So now I have asked the question that is, get me the topology details of my zOS system. So now it has selected the topology agent to do the action. And here we can see that it has selected the tool that is get system topology. And then it is also showing the output of the tool, if you can see here. And then we have got the final step, that is flow of the control back to the supervisor agent. And we have got the response over here. So now all this is in my local instance. Now how we can move that to a live orchestrate instance. So all that we need to do is we have to add the environment. So I have already added a environment for my live instance, and after that I just have to do issue and activate command to do this. So so this is my environment's name, and this needs an API key to connect to that environment. So with this, I can activate my environment. Now, as the environment is active and I have already validated my agentic flows, I can just issue the same import script, or the same commands of importing the tools and agents to the CLI, and that will import all the agents into the live instance. So here we can see this is my live instance, and here we have our agent added. And this is the UI for the live instance. And here we can see the description that we have provided for the agent in the YAML. And here we have the agent section where we can see the two collaborators, that is ServiceNow agent and topology agent. And we can see that the agent also has got one tool, and the ServiceNow agent has got around 3 tools. Once we have this verified here, we can also chat here and see if the things are working in our environment. So again, I'm just going to verify that it has gone to the ServiceNow agent, and I'm expecting it to select the get ServiceNow incident by number tool, and it has got its output from the REST API or the tool call, and it is finally trying to transfer the agent. And as we know, we will be going to get the response here, and it's nicely formatted here. And here, once we have verified everything, we can just click on deploy, and that will add your agent to this chat. So this will be the entry point for the user. So here we can select the agent that we have deployed and start interacting with the agent. So we can see that after deploying, the agent is working as expected. It has got all the tool calls correctly, and it is now trying to generate the final response. Yes, here is the final response from the agent about the incident 10219 that we had asked for. And just to verify, let's go to the topology agent. So here, the topology agent, what it is doing is it is connecting to the zOS MF APIs and trying to get the LPAR details. And with that tool response, we can see that here is the API response that contains the details about the zOS system. And it has now transferred it to the supervisor agent. And in few seconds, it will be generating the response. Yes. So it has given the good summary about what does the system details consist of, and a nice formatted tabular structure with the alpha details. So this is all about how we can use the agent development kit to build the agents with low code approach and with a very fast pacing development environment. Thank you.